Okay, it's recording now. Okay, so given a sample, what is the formula for the point estimate, p hat, for a population proportion? That's p hat equals x divided by n, and x is the number of responses and n is the number of trials.
Awesome. What is the formula for the one proportion confidence interval for one proportion? P hat minus, what do you call it, z star?
Mm-hmm. Or z times.
Just z? Yeah, okay. The square root of p hat times 1 minus p hat times n. Did I write that down right?
Divided by.
That's what I didn't write down. I thought that was wrong.
What is the condition required to build the one proportion confidence interval above? M times p hat is greater than or equal to 10, and then n times 1 minus p hat is greater than or equal to 10.
Okay, if no prior estimate for the population proportion P is available, what is the sample size formula to get the needed sample based on desired margin of error? Explain what each variable stands for in your formula. N equals z divided by m squared times p times 1 minus p. And z is confidence interval, m is margin of error, p is prior estimate.
Yeah.
I guessed on some of those, I don't know.
Yeah. And I just left the p out and did it, because if you don't have p, you can just do it without it.
Right. Okay.
What is a test statistic for hypothesis test regarding the population proportion? And z equals, which is your test statistic, p hat minus p divided by the square root of p times 1 minus p times divided by n.
Awesome. Okay, what are the conditions that need to be satisfied so the sample size is large enough that the sample limit theorem suggests the sample proportion p hat is approximately normal? N times p is greater than or equal to 10, or n times 1 minus p is greater than or equal.
Right. All right, confidence interval. In an October 2008 poll, 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. Find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So 684 divided by 1,006 equals 0.6799.
Okay, check requirements, projecting confidence interval for this data. And I said the requirements are met because 1,006 times 0.6799 is greater than or equal to 10, and 1,006 times 1 minus 0.6799 is greater than or equal to 10.
Right. So determine the margin of error for 95% confidence interval based on these. So 1.96 times the square root of 0.679 times 1 minus 0.679 divided by 1,006 equals 0.0288. So that's the margin of error.
Awesome. Construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years. So 0.6799 plus or minus 0.0288. So we're 95% confident that P is between 0.6511 and 0.7087.
Yeah, correct. How many calls should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015? So you take 1.96 divided by 2 times 0.015 and square it. You get we get a 4268.44, and you round up, so you get to a whole number of 4269.
Awesome. Okay, hypothesis test. Now you're interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.05. State the null and alternative hypothesis. Null hypothesis is P equals 0.6, and the alternative hypothesis is P is greater than 0.6.
Yep, so compute the test statistic. T equals 0.6799 minus 0.6 divided by the square root of 0.6 times 1 minus 0.6 divided by 1006, which gives you 5.174.
Okay, determine p-value based on the test statistic. Sketch your p-value on the normal distribution curve with the test statistic labeled. I did not get how they got p equals 0.
Well, it's like p. It's like 0.0000001 something.
Okay.
Because it's like a lot of zeros. So
Okay.
that's why
Gotcha.
it's 0.
Okay. Gotcha.
Because there's just a lot of zeros. It's so small.
Right.
So it's definitely less than 0.05.
Right. Okay. And then it just says to
So what?
sketch your p-value.
Yeah. So then when you put it on the normal applet, that shaded area to the right's very, very tiny. What decision do you make about the null hypothesis? Would you reject the null hypothesis?
Restate your conclusions. We have sufficient evidence to conclude that the true proportion of the fact in the last 5 years is greater than
Yeah.
Okay. So okay.
All right.
Okay. All right. So the symbol for the true population proportion is which of the following? P hat, right?
Right. So for the next two questions, suppose that n equals 100, p equals 0.25, and p hat equals 0.10. So the requirements for constructing a confidence interval are satisfied. So n times
0.25.
100 times times
Right, 100.
100 times 0.10, right?
I thought it was, let me see. Oh yeah, I was looking at the wrong part. Wrong one. Wait, isn't it just times p though? Or is it not? Or is it p hat?
It's times p hat.
Okay.
Which is 10. And it's 100 times 1 minus p hat.
9. So they're not satisfied.
Wait, you got 9? What did I do wrong? I got 90. 1 minus 0.10. I get 90.
Oh, I'm just multiplying it by 10. My goodness. Okay, you're right. It is 90.
Okay.
So it's
They are satisfied.
okay. The requirements for conducting a hypothesis test are satisfied.
Which is true because they're the same. Right?
Well, when do you do? Well, I guess the condition to build the one proportion confidence interval is just no. That is p hat. So what is is it ever just, let's see, the confident, on number 6 in our homework, what are the conditions that need to be satisfied to sample size large? Oh, to make it approximately normal.
Oh, P, you gotta do it by P. That's when you do it by P. So,
Okay. Yeah.
right, so we gotta do, that's when you do, so you gotta wait. 100 times 0.25. 25. And then 100 times 1 minus 0.25. 75. Okay, so use, wait, is it my turn?
Yeah, it is.
Okay, use the following information for the next 5 questions. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 the defendants were found guilty. Find the p-hat. Find p-hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in the state. Round to 3 decimals.
So 45 divided by 60, right?
Yep. So 0.75.
So 0.750, right? Just so we can round to 3.
Yeah.
3 decimals. Okay. Create a 95% confidence interval for the true proportion of first-degree murder trials in the state where the verdict is guilty. Input your answers to the margin of error, lower bound, and upper bound. Determine margin of error for the 95% confidence interval round to 3 decimals. So, let's see.
1.96 times the square root of 75 times 1 minus 0.50 divided by 75.
Mm-hmm. Is it 45 or is it 60?
Oh, I was looking at the wrong one. Sorry.
I think it's automatic.
It's 60.
Okay, yeah, no worries.
So 0.11.
Yeah, well, kind of 3 decimal. I have 0.109.
So if you're
So
on that,
yeah, I guess it would, I think it'd just be, well, yeah, would you go 0.110?
yeah.
Or would you just, you would,
Yeah, I guess you could. But
instead of, yeah, because you would round up from 9
yeah,
to 1.
I'm gonna plug this into the spreadsheet real fast. Make sure we did it right.
Okay.
Um, so then look at our upper bounds and lower bounds. So if we do, is that what it's asking next? What the upper bound and lower
Yeah,
bound?
lower bound and upper bound.
So
So I guess what we would do is that, right, 0.750 plus or minus
right,
0.
right, minus 0.11 is 0.64.
Yeah, one more.
And then the upper bound is 0.75 plus 0.11, which equals 0.86. And that's what it says on the spreadsheet. So we must have did something right.
Awesome. Okay. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? Increase, right? I think that's what we read. That it increases.
Is that what it said?
Do you remember different? Maybe I'm remembering wrong. I thought that I read that it increases.
I don't remember what I read because I read it at like 11:30 last night. So I'm gonna go with what you say.
Hopefully I'm not wrong. At least we have a second try.
Yeah, because I remember reading it, but I don't remember what it said.
Yeah.
Okay, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest n can be, and both requirements still be met?
How do we figure that out? Why, I don't feel like I even did a thing like this in the homework.
Okay, so that
One proportion. Would that be the
would be figuring out for n.
would it be the
And we know P, but we don't know the margin of error.
was it still that same question? Still margin of error is 0.11, right? Still from that other.
Did they say to do it?
What is the smallest n you need both margins? So I guess what we're gonna do, so you know on the homework on question number 3, it says, what is the condition required to build the one proportion confidence interval? So we just need to find the smallest n can be so that it still is equal or greater to 10. I guess we could do like trial and error. That's the only way I can think to do.
That's just a line. That's just a line.
Yeah, that seems.
That's just a line sound. That's just a line sound. There's nothing wrong with it.
The next two questions are exactly the same. There's got to be a way to do this without. Let me go look at the book fast because
It's the zoo.
that would be.
Let's go to the zoo. Let's go to the zoo. It's at the zoo.
Yeah, that's not gonna be.
Oh, it's at the zoo.
We could be at this for a long time.
It's at the zoo.
I think this answer is 20 though, for 11.
Do you?
Just with my trial and error.
Oh, okay.
Yeah, it ends up equaling 10 both times.
Is it gonna make the sound of
I think that's the smallest it could be. I mean, yeah, we can't get any smaller than that.
Okay. Well,
But
works
we
for
can
me.
find an easier way to do it.
a lion?
It would be nice, but if we can't, then I think that's the right answer.
Yeah.
Oh, the key.
Okay, so
So 1/10 now. Oh my goodness. 0.1. So I think this would be 100, is what I'm guessing. So 1 minus 0.1. No, wait. Times. I think it's 100. Because when you do it for the 1 minus p, it ends up equaling 90. But then if you do 100 times 0.1, it equals 10, and we can't do anything less than that.
okay.
I could easily be wrong. This is just me. I think this is right. I did the math for it. So,
Okay.
okay. Is it your turn or my turn?
You go ahead. I don't remember.
All right. Use the following information for the next 6 questions. For the water quality study in the reading, about 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect the water quality in the area has decreased. They conduct a hypothesis test using significance level of 0.05 with the following hypothesis. P equals 0.6, P is less than 0.6. They collect new data, and this time N equals 80 and X equals 38 indicate good health. For conducting a hypothesis test are satisfied. So 0.6 times 80. True. So you got
Yes, true.
okay.
So P, what is P hat? Round to 3 decimal places. I got 0.475.
I got that too.
Okay.
Okay, find the test statistic, round to 3 decimals. So it's going to be 0.475 minus 0.6 divided by the square root of 0.6 times 1 minus 0.6.
You. that?
Negative 2.282.
I have 0.181, but on the homework I wasn't getting it right either. And I think I'm just doing the math. I don't have I'm using my calculator on my computer right now, so I'm sure that I'm just doing it, not getting them right. You know what I mean? I wasn't getting the other one right either.
Yeah, that's I put it in
On the homework.
I put it in the Excel spreadsheet, and that's the same answer in the Excel spreadsheet too.
Awesome. So negative 2 point what?
282.
282. Okay. Was it you, I think? Or was it me?
What's that?
Was it my turn to read? Or was it your turn? I
Oh.
think it's
I don't remember. I'll read it. What is the p-value for this test? So we need the left side of the probability app, negative 2.8. 282.011.
perfect. 0.011. Yeah.
That's what it says in spreadsheet 2.
Okay. What is the decision for this test? It is 0.011.
Is less than 0.05. So
We were at check. Awesome.
So there's sufficient evidence. What we're doing is less than sufficient evidence to conclude that water quality in the area has decreased.
Has de-
Has-
Okay.
I can't get my phone. So,
Oh, dang, we got a few wrong.
okay.
A couple though. So I read that one wrong then. Number 10. Oh man. And number 1, I think is just P. Did you put there? I put P hat. I think it's just supposed to be P.
Population proportion.
Yeah, I think it's just supposed to be P. We were doing P hat. Dang it.
Okay. All right. But hey, we got all the other ones right. We got the hard ones right.
Yeah, we got the ones that are going to take time to do right, so that's good.
Okay.
Okay, tell me when you're ready and we can go through all these.
Okay. Okay. So number 3 is just P, right?
Yeah, I think so.
Number 4.
True. 5 true.
5 is true.
6.
Number 6.
0.75.
Okay. Number 7.
0.11. No. lower bound is 0.64. Upper bound is 0.86. Question 10. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? Now, I guess it's decrease. I don't think it would stay the same.
Yeah, no.
11 is 20. Good. Okay. 13 is true. 14 is 0.475. Uh, 15 is negative 2.282. 16 is 0.011. 17 is to reject the null hypothesis, and 18, sufficient evidence to conclude that the water quality in the area has decreased.
Okay.
Awesome, we got them all right this time.
All right.
Awesome.
Okay.
Okay. So I went onto that file and I just added a couple of things. Each of us, what we'd be in charge of. I wrote our names down. And you did a lot of it. You did you did all of it. I was just wondering,
I didn't.
it asks if it's quantitative or categorical, and I feel like it might be quantitative because we're looking for the number.
Yeah, I was like, I like I said, I was doing it at midnight last night, or 11:30, and
No
so
worries.
as I slept on it, and this morning, like, I'm thinking that it's more quantitative, and I'm thinking I wasn't sure about that one, and I wasn't sure about what type of test we would actually be doing. So
Yeah, I don't know either. So let's see. I'm gonna quantitative. And then, oh, I don't know either.
right,
So it's quantitative. So is it for number 6,
yeah,
3 or more samples?
yeah, that's
right?
kind of what I was leaning towards. That it would be in ANOVA.
I think you're right because we're all doing. There's so
Mhm.
many. There's 3 of us doing it, and we each have 5.
Right, yeah.
Okay.
And I was just picking a number, 5 bags each. We can adjust that, and
Okay. Yeah. I think 5 is fine. I think 5 is a good number. So then the null, because I want you to be able to turn this. I don't want you to have to do any of this.
yeah, no, it would be really nice to get it done. I have my son's graduating from college on Saturday, so we have a long Saturday. I'd like to get everything done.
Yeah.
So,
Well, okay. So number 7, then the null and alternative hypothesis.
that is that. That one is. That one's. It's just words that we have to write, right? That.
Mathematical symbols that appropriately define symbols that aren't obvious. So would we do like, oh?
Okay, hold on. I gotta look it up because all of a sudden it's like totally left my brain.
I think it's
HO equals Why?
What's
Why is it not coming to me right now?
me neither.
This is really bad. Okay, just a sec. What's that, chapter 14? Okay. All the means are equal. HO, all the means are equal. And HA, one or more of the means differs from the other.
One or more of the means differs from, okay, one or more of the means differ from the other or another.
From each other.
Okay. Whoops. Okay, cool. So then the sampling method, simple random sample sounded right to me.
Okay.
Completely random. I mean, there's no
Yeah.
like order to it.
Right. We're just going to go into a store and select 5 bags and
Yeah. So then I just added to number 9 saying, well, we will each
You're-
count.
you're like breaking up. I can't hear what you're saying. Okay, there. You were like totally breaking up. I couldn't hear you what you were saying.
Can you hear me now?
Okay, now I can, yeah.
Okay. Yeah, that was weird for a sec.
Yeah, you like were kind of gone.
How funny. I was just saying that for number 9, I added a little bit just so that, because it said for a person to be able to take this and replicate our study, I just added that we'll count the number of each color in each bag, and after recording the data individually, we'll report to each other to see what the outcome is.
Yeah, perfect. Okay, so please review the requirements in the text for your chosen method from step 6 and discuss why your study is in alignment with the requirements. Okay, so we will have 3 different groups.
Okay, so please review the,
Right?
yeah. Okay. Requirements, expiration. So I'm just gonna write ANOVA.
Well, yeah, it'll be more than 3 different groups because we'll have, how many colors will we have? Brown, red, right? Because we're comparing all the different colors.
Yeah, so we'll have more than 3 different groups.
Yeah.
And later we can write down the exact amount because I don't know what red, green,
Yeah.
I don't even remember the colors of them.
I can't either like right now off the top of my head.
Okay, we do the okay. And what were the other? What was the other requirements for ANOVA? I can't remember.
It is a test for equality of several means. It allows you to compare the means for several groups in one hypothesis test. So we'll have several groups and comparing the means of equality means of several different groups.
Okay.
Like on his knees. And like in the mark.
It's increasing.
Okay. I think that's good. I mean,
Yeah. I think so too.
okay, we won't involve human subjects. We won't conduct a survey, any of that, because we won't be doing any of those. Then we go to 19, and we just need to turn this in and have him
And sign it.
approve it.
Yep.
Yeah. So
Okay, good.
here's the thing. If Bryce ends up not doing it, technically, then I just send him one on here. So I said, like, you would do designing the study. We all submit the collected data document. I'll do describe the data. I just assign him to do make inference, take action. I'll do the PowerPoint, the main writer for the PowerPoint presentation. So if he doesn't show up to anything, just one we have to.
We can kind of work together too. It's
Yeah.
that'll be easy enough.
Awesome.
Okay, perfect. Thanks for your help with
Okay,
that.
Tuesday. Yeah, no problem. I'll see you Tuesday then.
Okay, and I'll get this turned in.
Awesome. Have a good weekend.
Thanks, you too.
Bye.
Bye.
He's all over the